In this video, I'm just going to talk a little bit more about raycasts, and I've just written a little tool that I will share with you where you can visualize raycasts and get used to how you might use them. So again, I'm in Unity here. Raycasts are broadly similar across most applications. But obviously we'll just be doing the Unity implementation here. So I've got a script that I've already written. It's over here in C#. So it's the Raycast demo script that I will share with you. And it's got a couple of features. The first area up here are just some publicly available parameters that we can control on the script, and the rest of these are private objects that are used throughout a variety of the different functions. Now the bulk of the work is done in this raycast function that I've written, and on update it just calls raycast every single frame. So every single frame it will call the raycast function, and the raycast function, first of all, it makes a raycast. Okay, so it creates a new raycast called hit, and then it performs the raycast. And we would normally perform a raycast within an if statement, and that is so that if the raycast is not successful, it doesn't need to do all of the rest of the associated functions, essentially. So we do the raycast within an if statement. And this will perform the raycast from the object's transform position. So whatever object this script is placed upon, that will be the origin point for the raycast. It will perform the raycast in a downward direction, and it will output a hit object. And the maximum distance for the raycast is set to raycast distance, which is one of these publicly accessible variables up here. And if it hits something, then it will define hit true as true. It will give me a hit point, which is the point in 3D space at which it hit another object. It will give me a hit normal, which is the normal of the object that it hit. It will give me a hit rotation, which is essentially the direction of the normal, so rotation from the up through to the normal. It will give me a hit distance, which is the distance at which the ray travelled to hit the object, and it will give me the name of the transform that it has hit. And that's all the raycast function does. The way that I'm using it is I'm using it to draw a bunch of gizmos or UI objects so that we can visualize the raycast function. Right, so let's go into our scene, and I'm going to create a new empty game object over here. I'm just going to call this raycaster, like so. And then I'm going to drag my script onto that object. Alright, and you'll see it's immediately given me a cyan gizmo, which is in the functions that I've written. It will only calculate the rays when we actually play the game or go into game mode. So let's go up onto my script up here, and there are some parameters that I need to complete before this will work. So the first one is a black texture. I just got a black image here. This is just to go behind the text when the text is drawn on the screen, so that there's a contrasting background there, so that it doesn't get lost in all of the texture detail that's in the scene. And then there's a P cylinder and a P cone, and I've just got a scene here that I've made in Maya, which has got some mesh objects within it. I'm going to drag those into these parameters, and if we hit play, So you can see we're getting a readout in game view. So let's switch to our scene view, and this is our tool in action. So it's not perfect. There are, the text is getting overlaid by the 3D objects, but that's okay. So what we've got is we've got a array being cast downwards in the in the down axis in the vector 3 world down, and when it hits the object or an object, any object with a rigid body or collider attached to it, it will tell you what it's hit, which is this is the name of the object that it's hit. It will tell you the position of the hit in world space, and it will give you the normal of the hit as well. So that's this readout up here, and you can see the normal direction of the hit on the yellow arrow. The distance that it took to hit the object is the cyan text here. So if I now move this RayCaster object around my scene, you'll see that all these values start to change as we start colliding or we start RayCasting into other objects. So this is really handy for a variety of applications. If we want to detect what we've hit with something, like if we're shooting bullets or whatever, then this is a great way of doing it. If we want to see what something would hit, then this is a great way of doing that. We can check which way an object should bounce off an object according to the normal direction. But mainly, like as technical artists, we tend to use this for procedural purposes, and probably the most popular application is in terms of placing objects dynamically. Essentially what this function allows us to do is to spawn an object up here and then cast a ray downwards to see where the ground is, and then we can place the object on the ground, and if we want to, we can orient it to the ground as well. So that is quite a common use case for the RayCast function.